Hello friend, my name is Dark Harder, and in this video I just wanted to give a quick introduction to some of the basics of computers. So we're starting off on this course. This is some video for our application program development course. It's good to make certain everybody has the kind of a basic understanding of sort of how computers work and the components and things before we get into actually programming. Okay, so with that, let's go ahead and get started and mention a few things. By the way, for all these series of videos, we are kind of following closely along with our textbook. I am using the 5th edition of the Tony Gaddis starting out with Python textbook in order to develop the materials and things for our course on application development. So these slides, I'll add in kind of my own examples and things, but these slides and materials and things are mostly coming from our textbook here. Okay, with that, so let's go ahead and get started then. Okay, so I just want to make sure everybody kind of has a basic understanding of a few concepts before we get into actually writing programs with Python and doing some program or application development. So first of all, everybody who's taking this class should understand that computers can be programmed basically to do any kind of job that we want them to do. Okay, so computers are programmable devices, right? So they provide a set of very simple instructions, and then we can use those instructions to build complex applications. So that's kind of what this course is about. So a program is a set of instructions that a computer follows to perform some task. So we commonly refer to that as software. All right, and so you're probably familiar with lots of different kinds of application programs that users typically use on computers. So web browsers, text editors, programs like that, video software editors, video players, games, like that. Those are all examples of application programs or software that can be written and be used by users. Okay, so the people that create these programs are known as programmers. They're the people who design, create, and test computer software, okay? Also known as software developers. So it's good to have a fundamental understanding of the basic components of a computing system. Okay, so a computer consists of hardware. These are the physical devices that make a computer. And we typically think of a computer as being broken up into these major components: the central processing unit, main memory, also known as RAM or random access memory, secondary storage devices. So these are usually hard drives or more commonly SSD drives in modern computers. So solid state devices, and then input and output devices. Okay, so the core of a computing system that makes up its address space is the central processing unit, the CPU, or the processor, and memory. Okay, so this is the central part, right? You can think of secondary storage. This is a place where files are stored and programs are stored, but in order to actually run anything, we have to load programs and data off of secondary storage into primary memory before we can actually run any action programs. And then you have your input devices to get data in. So in this class, we'll mostly be using the keyboard to give us input on a terminal, and your various output devices for sending results out. And again, we'll mostly be using a terminal on a display to see and work with the output from the programs that we write in this class. So everything that a computer does is controlled by software. Okay, and we can broadly divide software up into two classes. So you can think of application software. This is the stuff that you're probably mostly familiar with. Whenever you use a computer, most people are users and they want to run an application. So your word processing software, emails, web browsers, photo editing, games, and things like that. Programming editor, maybe I should have put this down here into the other category. So the other sort of broad category is systems software. So these are things that manage the basic operations and resources of a computing system. So fundamental of those would be the operating system itself. You can think of system software. It is a piece of software, but it has special privilege to manage and control the devices and the operations of a computing system. Utility programs, so an operating system the utility programs might be part of the operating system, or they might be separate from them. And then software development tools are kind of important for this class, because these are tools that usually regular users aren't going to use these, but people that need to build and create application programs need to use software development tools. So you need to use something like an IDE, an integrated development environment, or at least a programming editor, in order to create the Python programs for the assignments for this class. Okay, so all data in a computer is just really just a sequence of zeros and ones, all right? So a byte is a fundamental size of data that we use in a computer. It's just big enough to store a single letter or a single small number. So a byte is really just a grouping of 8 bits, okay? So a bit is just an electrical pattern in the computer somewhere that can hold either a positive or a negative charge. And so we interpret that positive or negative charge as either a 0 or 1. So that on-off pattern of bits in a byte represents data stored in that byte. Okay? So you can think of a byte just as simply as just 8 switches, on or off. So we can use bits or 8 bits in a byte to represent basic things like a number or maybe a character or other things, right? So so computers use a binary numbering system. So when you have a byte or 8 bits, something like this just represents, if we interpret this as an integer, this represents the integer 77. Because this is the 2 to the power of 0 place, 2 to the power of 1, so on, right? So this is 2 to the 6 plus 2 to the 3 plus 2 to the 2 plus 2 to the 0, which is 77. And so when you have 8 bits, if you want to represent an integer, you're pretty limited. If all the bits are 0, that represents 0. If all the bits are 1, this is going to be 2 to the 7 plus 2 to the 6 plus 2 to the 5 and so on. So that's 255. Right? But we can use 2 bytes to store a bigger number. And if we need an even bigger number, we can use 4 bytes or 8 bytes. So data stored in a computer must be stored as a binary number, okay? And we can represent other things than numbers. So another common thing that we need to work with, especially in this class, are characters or textual data. So characters are converted to a numeric code that we can interpret as characters. So if you're not familiar with this, you might want to take a look at the ASCII table. So this is actually in Appendix C of our textbook. So really quickly, if you go here and look at Appendix C, you can get the full ASCII code character. This is really just a mapping. Actually, only 7 bits are used for the ASCII character, the original ASCII character set, right? So you can see what the whole 128 characters that are available. The basic ones are the upper and lowercase English letters, and then also the numbers and things are part of the ASCII character set. Nowadays, we would actually probably be using the Unicode encoding for character data. Okay, so this is compatible with but extends ASCII. And when we're writing stuff for this class, you probably won't really have to know this, but it's good just to mentally understand that underneath the scenes we're representing characters that we use in strings. It's really just a mapping from a character to a bit pattern in memory, right? And we can use Unicode and encoding to represent other languages. So originally we had ASCII for the English language, but we have encodings for pretty much all the world languages are defined for the Unicode encoding. And then finally in this video, we'll just mention that, if you need to store something other than a integer, you have to come up with some other kinds of schemes or encoding. Okay, so in this class, when we do your applications, you will have to do a lot of stuff with real valued numbers or floating point numbers. Okay? So there is, for the interested student, there is a standard called the IEEE 754 standard that defines how real valued numbers are stored in a computing system. Okay. And by the way, if you want to represent negative numbers, but you still want to have a whole number, an integer, but be able to represent like negative numbers, negative integers as well as positive integers, that's another type of encoding called two's complement. And there are other kinds of data. So digital data describes any kind of device that stores data as binary numbers, right? So there are encodings and standards for images. So these are like your JPEG and your PNG images. Those are a standard for how you represent the pixels in an image, convert that to a binary number to represent the color value. And video standards really is just a sequence of digital images, right? So if you display 30 images in a row per second, you will get the illusion of video. Right? Likewise, you have to encode audio if you want to have a video, or if you want to play music on your computer. Those use a digitized sound sampling process where the sound level again is converted to a binary number, and you can use that to drive the output of the speaker. All right. Okay, so a quick summary of what we covered so far in this video. So in this video, you should have learned about the idea that an application program is a piece of software created by programmers, and so the fundamental subject of this course is learning the beginnings of how this type of application software is written by programmers. Okay, you should at least be familiar with the basic hardware components of a computer, what they do, how they're related to each other. So the CPU, the main memory, secondary storage, and I/O devices for getting data in and out of the computer. You should be aware of the fact that all data in a computer is stored as a sequence of zeros and ones. Okay, so a byte is a fundamental unit of a computer data, which is really just a grouping of 8 bits. And we can use multiple bytes to represent bigger things, so bigger numbers, and not just numbers, but we can use different kinds of standards to digitally represent other kinds of data. So the most important kinds being images, video, and sound, among many other different data types that we can represent on a computing system and work with in application programs. Okay. So that's it with this video. I hope these things will be useful to you. So please go ahead and go on to the next one. We will begin, actually doing examples with Python stuff here real soon as we work through the materials on textbook. Okay, so I hope to see you in class or in the next video.